Starting a new chapter. So far, we've talked about natural numbers. Those are 1 to infinity. Then we moved on to whole numbers. Those are from 0 to infinity. Then we went on to integers. Those go from negative infinity to 0 to positive infinity. For example, these are integers. If you're looking at this, one thing you can observe that as we go through these number systems, these are called number systems. The number of things we're talking about increases. This one goes from 1 to infinity. This one has one more than that one because it has 0. This one has twice as many because it goes from 0 to infinity and it goes from 0 to negative. So it's twice as big as the whole numbers. Now, what about numbers between integers? Those are what we call rational numbers. These are the numbers between the integers. We've just now exploded the number of data we have. There are an infinite number of values between 0 and 1. So yes, when I said exploded the number of values, that's what I mean. Because that's just between here, between here, and it goes on infinitely. So that's a pretty big jump of numbers that we have. How do we do that? Rational numbers have the form A over B. This came from this is the result of this equation. Is that true? How do we get this from this? So we're saying that x is equal to A over B. Nope. Oop. Oh, I got it. A equals BX. There. So you're correct. It wasn't true.
Oh,
And this one's true. Because in order to solve for x, what do we have to get rid of? We have to get rid of b. How do we get rid of b? Yeah. So if a equals bx, then we divide both sides by b, then x equals a over b. Okay. Depending on which grade you teach, let's look at the nomenclature. In other words, let's look at the words we use. In elementary school, we call the top number the numerator. The bottom number is called the denominator. Used to be called the numerator. That's an R. But now we just call it the denominator. This is elementary school. Then when you get to fifth grade or higher, fractions have a different name. The top is called a dividend. The bottom is called a divisor. And the answer is called a quotient. Plus a remainder if you have one. Plus R. The only rule that must be followed is that b cannot equal 0. Why? You can't divide by 0. Remember, 0 over 1 as opposed to 1 over 0 have two different answers, two different meanings. If the 0 is on top, The answer is 0 because 1 cannot go into 0. It goes in there 0 physical times. But 0 can go into a number an infinite number of times. That's why it's undefined. Because infinity is not defined. That's why whenever you see a rational expression, it will include the statement the bottom cannot equal 0. For example, if I give you this, I will have to have it followed by x cannot equal 0. Why? Because if x is 0, then the bottom is 0. 2 times x equals 0. So x cannot equal 0. We would take this. Yeah, we're still talking about the nomenclature here. Rational numbers. What's another name for rational numbers? That's one. What's another one? What's that? Good. Yes and no. It's not called a decimal because it's the fraction of number over number, but it gives birth to decimals. So you're just one step ahead. Instead of fractions, we can call it. When I say find the quotient of these two numbers, it means take the first number, put it on top, the second number, put it on the bottom. Find the quotient of A and B means A divided by B. So whenever you get a word problem, whatever comes first goes on top. Whatever comes second goes on the bottom. The word fraction. Why do we call it fraction? Everything's Latin based pretty much. If you think about it, when you go to a doctor and your arm is broken or partially broken, what do they call it? If it's not all the way broken through? Fracture. Fracture. It simply means it's broken. It's in multiple pieces. In Chinese, this is in Latin. In Chinese, the fraction is read out of B part take A. That's a very logical way of thinking about it. If we think of 3/5, how would we introduce that to our kids? Right, yeah, that'd be the first one. Break the chocolate bar, break it into 5 pieces. We have 5 pieces there. They're not equal, but they're supposed to be equal. So we have 5 pieces. Take 3. That's what it represents. That's what it answers equal to. Let's look for, oh. Different ways we can use the word fraction or rational. Okay, here's the first one. The division problem or the solution to a multiplication problem. The solution to 2x equals 3 is 3/2. Bless you. That's one use for fractions. The second is portions or parts of a whole. I got 1/2 of my brother's pie. So we're taking part of it out of the whole. It could be a ratio. The ratio of Republicans to Democrats on in the Senate is 3/5, or it could be written as 3/5. That's a ratio. Again, a ratio is part of a fraction. A portion is a part. And the last one is the probability. If you ever take a probability course, or actually you hear it all the time, the probability of something to happen is what? How do you define something to happen? The probability of flipping a coin and getting a tail is 1/2. This is the part over total. Ways to represent rational numbers. Ways to represent rational numbers. Bar or wheel model, where we can have so if we say 1/3, that's what means the same. Number line. So between, if we use something with a bar, if we use a bar, this could be 0 and this could be 1. We're separating it in different parts. So if you think about it, what is this first part? That's the first of 3 parts. That's this part. What's this part? That's the second of 3 parts. What is this one? The third of 3 parts. 3 over 3 is equal to 1. So this is the same thing as the other two. And the last one is parts of a set. Here we have 12 total. And I only want 5. So fractions really mean part of a whole. Fractions, the part that you have, part looking for, total number of parts. So far, so good. We're still repeating, because if you think about it, besides word problems, the next part that students don't like the most are fractions. And after that are negative numbers. So I'll make sure you understand all these words. So the part to a whole model. A over B, where A and B are integers, and B does not equal 0. We must consider the following. One, the whole in the question. The number of equal sized parts. B, that the whole will be divided into. The number A of the parts of the whole we want. Whatever you define A over B, you have to know what is your total? How many total parts do you have? And then how many of specific pieces of those parts do you want to take out? Proper versus improper fractions. What's the difference? Proper fractions. A over B, where A is less than B. Improper fractions. A over B, where A is bigger than B. For example, a proper fraction would look like 3 out of 5, or 3 over 5. Which means you'll always have some left over in that fraction. But as opposed to an improper fraction where the top number is bigger. So what's the difference between these two? This one is less than 1. This one is greater than 1. If a number is as a proper fraction, leave it alone. If you have an improper fraction, then change it into a mixed number. Okay, let's look what that means. Let's say we had 5/3. That's improper because the top number is bigger. The way you would represent this, the denominator tells you how many times, how many cuts do you make between 0 and 1? We have to have 3 units. So if there has to be 3 units, that means there has to be 2 numbers inside there. Because here's the first set, second set, and third set. It has to be kind of 3. Let's put all of these into 3s. If you here's something that they don't talk about. The bottom number tells you how many times you cut up the number between 0 and 1. Which means if you want it to be thirds, that means you have to have 2 numbers inside there. If you want it to be in fifths, how many numbers do you need? 1, 2, 3, 4. Here's 1, 2, 3, 4, 5. It's always going to be the bottom number, b minus 1 intervals or sections. So if you have a 3 on the bottom, that means you have to cut that into you have to put 2 numbers in there that are all even spaces. If you want a 5, then you have to put 4 sections inside there because the last one's going to be counted also. So 5/3. Here's 1/3. This is 2/3. This is 3/3. This is 4/3. And this is 5/3. So this is how much 5/3 would look like. But if we look at it, it's passing an integer. So we know that this one automatically appears in there. And we have to add 2 more thirds. So we have, whenever you have an improper fractions, you'll go past an integer or multiple integers. However many you pass, you have to put that number down. And then the last set, you'll see of how many parts are in there. So your answer will be that. That is a mixed number. where A is the number of integers that are solid integers that are in that number. And B is the leftover amount. So let's do the example 1. Place these on a number line. Place those on a number line. How do we find 1/2? Is it a proper or improper fraction? It's proper, that means what? It's less than 1. So we know it'll be somewhere between 0 and 1. We cut that into 2 parts. So 1/2 is right here. That's that much. Negative 1/2, it's on the negative side, and it's less than 1 also, so it's between 0 and 1. Make it into halves, and there's your 1/2. Negative 1/2, that's where it's located. What about 7/4? How many pieces do we need between 0 and 1? We need 4. So how many bars we put in there? We have to have 1/4. This is 2/4, which is 1/2. This is 3/4. This is 4/4. Keep on going. This is 5/4. This is 6/4. 7/4. And 8/4. So we're looking for 7/4 right here. It goes from 0 to 7/4. This is 0 to 1/2. Same thing in the other direction. We want negative 7/4. So we have to cut this into fourths. So it's negative 1/4, negative 2/4, negative 3/4, negative 4/4, negative 5/4, negative 6/4, negative 7/4, negative 8/4. We want negative 8 or 7/4, which is there. So it's there. So that's how you find numbers on a number line. Any questions? All right, let's look at equivalent fractions. So as a teacher, you could introduce fractions. How would you do it? How would you introduce fractions to us to your class?
Slices of pie.
If you brought a pie, yes. But how you demonstrate it to them?
Slices each of it and slices not.
Yeah, that's a concept that they have. You have to physically see it. So you'd have to have a pie in front of them, So I'm gonna cut this up into 6 pieces. I'm gonna eat 1 piece. How many pieces I just have? You can't do that. Paper. Folding paper. You can fold a paper in half. What if you fold that half of paper in half? How many pieces do you have now? 4, because you folded a half and another half. So as you go on, you could introduce multiplication of fractions. So here we're going to look at A over B equals C over D. How are fractions equal? So if we look at a piece of paper, if we fold this into thirds, so this is how much? One third. Okay, so remember, we have this folded piece of paper, it's in thirds. Okay, let me demonstrate. Here we have a paper folded in thirds. Now, if we fold that in half, how many pieces do we have? We now have 6 pieces. Remember, this is still our thirds. But this was cut in half. So this half is now written as what? It used to be 1/3. It's now what? It's two pieces out of 6. Let's go one step further. Kind of like an infomercial. Let's do it again. Now, how many pieces do we have? And now we have 12 pieces. So in this first part, we have 1, 2, 3, 4. We have 4 out of 12. These are all equivalent fractions. They all mean the same thing. They mean this first third of this folded piece of paper. Yeah, seeing is, and then you have the kids do it at their table with their folding. So that's what we call equivalent fractions. So if we cut these in half again, this third is now 2/6. And if we folded it again, so this part is now 4 out of 12. They're all equal to each other. This is how you introduce equivalent fractions to them. In your classroom, and you'll have posters all over your classroom. One poster you could have about fractions. Then this is a number line. So this whole thing is from 0 to 1. What if we cut it here? What do we have now? We have 1/2. What if we take that one and cut it into thirds? Oops. So this is 1/3. This is 1/3. This is 1/3. So from here, this is 1/4, 2/4, 3/4. These are all 1/4 of a unit. And we keep on going further and further and further with that. It's a poster you can have in there. And this will show them equivalent fractions. You can see that 2/4 is the same as a half because they take up this much of the line. You can say that 1/3 is the same as 1/6, 2/6. They're the same values. 1/3 and 2/6 are the same value. But you'll have that in your as a poster in your classroom, or a lot of teachers do have those math posters. Constant multiples. What is a constant multiple? No, it means it's a solid number. Constant multiple simply means that if I have number A over B, and I multiply both top and bottom by the same number, I get the same answer as I started off with. In other words, 1/2 is the same thing as 3/6 is the same thing as 5/10. So as long as I keep multiplying the top and bottom by the same number, it doesn't change the basic idea of what the fraction is. (6-1). The fundamental law of fractions. If A over B is a fraction, and n does not equal 0, then n times A over n times B is the same as A over B. This is a pretty powerful theorem. Why? Because remember, do the students know anything about cancellation and fractions? No, but some of them may. If the same thing's on top and bottom, what happens? So you will have introduced to them that what is 3 divided by 3? What is 5 divided by 5? So if you have the same number in top and bottom, that equals 1, which is what this is telling us. What this is telling us that we have our fraction A over B, and we multiply it by n over n. So this is where we're coming from. N times A over n equals, well, A times A over B, and n times n over n is the same thing. I can take them out. This we know equals 1. So we have A times B times 1, which is A over B. This is where we talk about cancellation or simplifying fractions. The definition states this. A rational number A over B is in its simplest form. Always. If and only if, which from now on, I'll simply write IFF for if and only if. The GCD of A and B is equal to 1. What's GCD stand for? The greatest common divisor. What's the largest number that fits into both of them? If the greatest common divisor is 1, that means if A and B have no common factors other than 1. So that's what they're trying to tell us. And here we can introduce this concept to them. Well, we just did. We just talked about it here. For example, we had A times N, B times N. Do they have anything in common, top and bottom? Yeah, the ends. We can remove the ends because N over N is 1. Now we have a fraction in its simplest form. They have nothing else in common. For example, simplify this example. 60 over 210. What do we know? Since it ends in a 0, what do we know about the number? It's multiplied by a 10. So this one ends in a 0, so it's 21 times 10. Do they have anything in common? Yes. The 10s, they can cancel. Now we're 621. What is 6 made up of? 2 times 3. What's 21 made up of? 7 times 3. They both have a 3 in common, so they disappear. So our simplest form is 2/7. And we learned how to factor earlier. So this is where the whole thing comes about. Example 2. Is this an expression or an equation? No. It's got an equal because that equal sign, it's an equation. Equations always ask you to solve for a value. You're not done until you know what the answer is. Equations only simplify. This was an example of an expression. All we can do here is simplify. That's an expression. In this one, you have to solve for it. Solve for what? Solve for x. So how do we do that? There are multiple ways, actually. Well, first off, let's look at, here's the first method. Do 42 and 210, do they have anything in common? In other words, if they have anything in common, it'll come out here. So let's see. So what is 210 made up of? 21 times 10. 42 is made up of what? 7 times 6. Oh yeah. You could have said, yeah, you could have said that. You say 21 times 2. We could have said that. Yeah, that's a very good one. I didn't see that one. Very good. And then we have 10 over 2. What is 10 divided by 2? 5. So what does this tell us? We know that 21 over 42 is equal to 5, right? So what we learned last time was 21 or 210 is the same thing as 5 times 42. True? So what this tells us in our equation, so 12 over 42 equals x times 210. If we take 42 and multiply it by 5, we get 210. So whatever we do in the bottom, we have to do on top. Right, so this is going to give us 5 times 12 is 60 over 210 equals x over 210. Whenever the bottom numbers are the same, your answer is whatever's on the top. So x is equal to 60. That's one way you could do it. Another way was what you were saying of the cross multiplication method. But the problem with the cross multiplication method, well, let's look at what happens here. Let's look at what happens here. We have, what are the numbers? We had 12, 42, x over 210. So with cross multiplication, we have 12 times 210 equals x times 42. Right? Then what do we got to do? Now we have to divide by 42 because we're looking for x. We just moved this guy back to where he was originally. So cross multiplication has always been a very, to me, I've never understood it, because you have to undo something, then put it back together where it was. So x is equal to 12 times 210 over 42. Well, we know that 42 goes into 210 how many times? That's another way. So here's an example. (28) AB squared over 42 A squared B squared. First thing you have to do is look what they have in common. What do they have in common? What else? Well, first look at the numbers. What do 28 and 42 have in common? Well, for sure by 2. Yes, so we have 28 and 42. 28 is 2 times 14, 2 times 7. 42, 2 times 21, 3 times 7. So we have 2 times 7, they both have in common, which means we have 2 times 14 on top and 3 times 14 on the bottom. Now let's look at these guys. How many, do they have any A's in common? They only have one A in common. And how many more does anybody else have? There's one more on the bottom. So put it outside the parenthesis. They both have B squares. So remove what they have in common. So the 14 goes away. Okay, so we're left with, that's our final answer. That's our simplified form. How about this one? On top, we have A plus B, A plus B. What does the bottom have in common? They both have a 3 in common. So I take out the 3. What am I left with? So remove one A plus B. What I'm left with is A plus B over 3. These will get progressively more difficult as we go along. The third one, C, is x squared plus x over x plus 1. What do they have in common on top? They both have an x, so I can take out the x. Now what do I have in parentheses? No. Because we took away the x. To see what goes in there, whatever we factor out, go back to the original equation. We have x squared plus x. Divide both of these by what we factored out. We have x squared, we took out an x. So what is x squared divided by x? Yeah, there's two x's here, one x on the bottom, one of them are gone. So we just have x. Plus, what is x over x? 1. You have to be able to go both directions. I can factor and go here, or if I multiply, I have to come up with this. Can't factor anything out of the bottom. No. So I can't cancel anything. So the answer is x. No, it just means x is x. X is a variable, it could be anything. 3 plus x squared over 3x squared. Do they have anything in cancel? Are you seeing? Okay, very important, because here's what I'm going to get to. 2 plus 3 divided by 3. What does that equal? What is 2 plus 3? So we have 5 over 3. What you're suggesting is I can cancel the 3's. If I cancel the 3's, what do I have left? You made 2 mistakes there. When you divide, what is 3 divided by 3? So this would be 1. So it's 2 plus 1 is 3. Are they the same? No. Because there's a plus and minus on top, it treats it as one number. You can't cancel anything unless it can be factored out. You cannot discriminate on which ones you cancel. So this one's as far as it goes. It cannot be simplified. 3 plus 3x squared over 3x squared.
That equal?
Well, what can we cancel? What can we factor out? Can we factor out x squared out of this one? No. So what on the top? Treat the top and bottom separately. What can we factor out of the top? They both have a 3. So what do we have left? If we take out a 3, what do we have left in there?
That'd be 1 plus x squared.
1 plus x squared. Now, remember, it has to be the same top. You can only cancel if it's multiplied or divided, not when it's added or subtracted. So the 3's can now be canceled because they're both coefficients. What this one looks like is 3 over 3 times 1 plus x squared over x squared. These cancel, so we're left with that. That's our answer. And don't feel bad. You guys fell in the same trap that millions and millions of other students throughout history has always fell into. But this is what this is all about. That's reasons people don't like fractions, because the rules are very, very, very specific in which we have to follow. What if we had this? What is my limitation on x? Remember, we have a fraction. What x can I not use? Remember, what's the only rule here? You have a fraction. What can you not have in a fraction?
Can't use it.
No, you cannot have what in a fraction? On the bottom. The only rule you have here is the bottom of this fraction cannot equal 0. So what would x have to be to equal 0? So that is the only x I cannot use. Whenever you have a fraction, that's the only x I cannot use in my answer. So whenever you have fractions, first thing you have to look at, what are my limitations? It's called a domain. What x's can I use? Equality of fractions. We have 3 methods to prove if 2 fractions are equal. We'll use these numbers, the same ones we used earlier. Are they equal? Don't go too quick on this because you don't know. You haven't worked out the question yet. So the first method. Simplify both fractions. So we have 12 over 42. Simplify that one. What is 12 made up of? What's 42 made up of? Four times 7 is 28. 6 times 7. Okay, so what is 4 made up of? Nothing cancels there. What is 4 made up of? 2 times 2. What's 6 made up of? 3 times 2 is 6. Now, since we have numbers on the same top and bottom, the 1, 2 can cancel, and the 3 can cancel. So we have 2 over 7. That's what the first one equals. How about 10 over 35? What is 10 made up of? 2 times 5. What is 35 made up of? 7 times 5. Can anything cancel? 5s. So we get 2 over 7. Guess what? They're the same fractions. That's why you never, ever, ever spit out an answer in mathematics. You answered, no, it's not, because they look different. Again, that's not mathematics. You have to work it out. Yes, they are the same. That's the first one. The first method is to simplify both fractions. What numbers do I use? 1242 and 10 over 35. Common denominator. That's the next one. This one has 2 parts. Least common denominator, or just a common denominator. So what is the LCD of these 2 numbers? Remember how we found the LCD? $35 is made up of 7 times 5. That's as far as it goes. 42 is made up of, we found those out, would be 2 times 3 times 7. Six times 7. So what's the LCD? Okay, so they have 7 in common. So 7 times 42 is what? Now that's what they have in common. How are they different? This one has a 6. This one has a 5. So this one has a 5. This one has a 6. So we have to multiply this one by 5 and this one by 6. Because that's how they're different. Because now, if you think about it, they each have the same makeup of numbers. 5 times 12 is 60. 5 times 42 is 210. 10 times 6 is 60. 6 times 5 is 30. 18 plus 3 is 21. So they're both the same, so they're equal fractions. Or the last thing we can do. The last thing we can do is I have 42 here, multiply it over here. I have 35 here, multiply it here. So what is 42 times 35? 10. That's 21. 6 and 12. So this bottom number is 1470. This bottom number is 1470. All we have to do now is multiply the top. 35 times 12. This is 420. 42 times 10 is 420. So they're equal. So those are different methods. You can find the LCD or just multiply the denominators. Because all we're doing is saying, are they equal? So that brings us to theorem. 6-2 equality of fractions. If A and B and C over D are rational numbers, and B and D do not equal 0, they are equal if and only if A times D equals B times C. So 12 over 42 is equal to 10 over 35 if and only if 12 times 35 is equal to 10 times 42. And we just figured that out. It did. So it's 1470 equals 1470. Ordering rational numbers. Is this a true statement or not? Why not?
Because 1/2 is greater than 1/3.
How do we determine this mathematically?
On the upper line, 1/2 is closer to 1 than 1/3.
Yes. Is there another way? We have decimals. We haven't got decimals yet. We deal with rational. Well, we get common denominators. So the common denominator here would be, I take this number, multiply it over here. I take this number, multiply it over here. So I have 2 over 6 is greater than 3 over 6. Is that true? No. Or another way we can do it. We can follow the same rule. Treat this as an equal sign. Cross multiply. 1 times 2, 1 times 3. Is 2 greater than 3? No. These are multiple ways you can do it. Finding numbers between fractions. So if I had 2/5 and 3/4, find me a number between there. The formula says this. If A over B is less than C over D, if that's true, then we can find a number between there by taking the numerators and the denominators and add them together. This number will be between those two. So in this example, we have 2 plus 3, 5 plus 4. So we have 5/9 is between those two numbers. So using this formula to find numbers between sets.
We don't need a common denominator.
Nope. That's the beauty of this formula. If I had more time, I'd drive it for you, but that's the beauty of it. We can check, let's check it out. 3/5 and 4/5. Let's find a number between there. Oh, no, let's do some 3/7 and 5/7. What number is between there? 3 plus 5, 7 plus 7. So we have 8/14, which is 4/7. And 4/7 is between those two. So it works. I know. When I first thought that doesn't work. Prove it to me. And that's why. That's all right, everybody. That's the end of that section. We're almost getting there. Have a great day. I'll see you on